If you want to run a parametric study with AlphaCell, you have to open a Python script like the one I will send you in the email, which is run parametric AlphaCell perf plate circ with plenum. So we will use a perforated plate with circular perforations backed by a plenum. So if you open this Python script, you will find this file. You just have to change the path for AlphaCell, which is at the top of the script file. If we scroll down here, you will find some information, some tables to define parameters. So for example, here is a variable to define the thickness of the perforated plates. So we will, for example, study plates with thicknesses of 0.5 millimeter. So each units are in USI. So it's 0.5 millimeter, so 0.5 at 10% minus 3 meter. And another plate thickness, which is 1 millimeter. We will also study the porosity, the perforation ratio of the plates. So here we will just test, for example, 0.1 of perforation ratio. If we want to add another value, we just have to add a comma and a new value for this perforation ratio, and we will also test values for the radius of the perforation. And correction is just some correction due to the perturbation of the flow when the wave propagates through the perforation plate. So here with a plenum at the back of the perforation plate, you just have to enter static. You can add a dynamic if you want to add some porous material behind the perforation plate, but for the example we'll keep static here. And then here is a loop to go through all the parameters value that we have defined in this area of the script. So this is just basically a loop over all parameters value here. And now we go down on the Python script file. So you will find this first loop just generates the all the data sets that we will test, and then there's a second loop which will go through each of the data set values, and for each value we'll create a file which will where we will save the results, which will be AlphaCell in underscore and the value of a numerical value .xml, and this file will be the file that will be used by AlphaCell to run the simulation. So here you can change the values for the frequency. So this is the minimal frequency, the maximal frequency, and the number of frequency. You can add some scale if you want for a logarithmic or a linear scale for the distribution of the point of the 100 points between 20 and 5000 hertz. Noct is if you want to use octave bounds, and here you have the definition for the temperature and the pressure. Here for the windowing, if you want to add some windowing by Vigran or Razi, for example. And in this part of the script, you will define the if you want to run tests for in absorption or in transmission. So here we have absorption, which is true, so we will compute absorption coefficient. In diffuse sound field, and here you can find all the possible values. And this is the maximum angle value in degrees, so we'll keep this value. Here you have some definition of all the possible layers then we can add with the, for one layer for example, you have all the parameters you need to enter to run a simulation with this type of material. If you want to add elastic model, of course you have also to add some information, and I will just show you. So this is the end of the file. Here we will add first, so at plenum we will go from the end of the multi-layer system. So the first material is the end of the multi-layer system, and the second one is in fact the one for which we have the excitation, which is on the excitation side. So here we have we have a plenum. So the acoustic model is air with a thickness of 200 millimeter, and you just have to enter the values for the parameters. So for the air model there's no parameter, for the acoustic model none for the elastic model neither. And then we will add a perforated plate with circular perforations, and then we will add, so this is the name of the acoustic model, and we will add the values of our data sets. So these are the values from the 1, 2 and 3. So perforation ratio, radius and correction, and the first value of our data set is the thickness of the plate. This is what you can find here in the thickness field. We have no elastic model, so no elastic parameters, and no heterogeneous model, so no parameters for this model. And then we run the simulation for this specific case in the loop, and we will then go through all the loops, all the values with this loop. So I will run the simulation. So opening a command window, I will just enter the name of the file. So this one is perf plate circ with plenum, and AlphaCell run the test, and we can see here all the results. So the XML file are the file which are generated, and the rock file are the results for these generated files. And then you can open AlphaCell. So I have mine open here, and we can create a study, and then you can drag and drop the results which are here. Okay, so we can see the results, and if we go back to the terminal window, we can see here, okay, this is the table of all parameters value. So the first simulation, which is AlphaCell in 1, is in the case we have a thickness of the perforated plate which is 0.5 millimeter with a perforation ratio of 0.1, a radius of 50 micrometers, and a correction of static. And then of course AlphaCell in 2 have these parameters, and so on. And of course don't look at the information here, because you just have I just have made some drag and drop of the file, so it have not changed the information on the tube, but everything is written in the Python script.